Welcome to the Actuarial Data Scientists. Today's problem is, I think, deceptively challenging. It looks pretty straightforward, but can be a bit difficult. However, in terms of required knowledge, you actually only need to know how to calculate an expected value, integrating over the PDF multiplied by the value of interest, so probability weighted average, as well as converting a CDF into a PDF just by taking the simple derivative. I also have linked here the PDF that Mahler has of his solution manual to the exam, and I'll leave a link in the description of the video, but just wanted to mention this because he has two alternative methods for solving this problem in addition to the one we're going to be walking through. And that is manipulating the distributions to eventually come to the realization it's just a Pareto distribution, at which point you can go to your formula sheet and just plug and chug the alpha and theta values to get your expected value. However, I prefer just looking at calculating the expected value, and so that's what we're going to move forward with. To calculate the average, you're going to say what's the value and then multiply that value by its probability, because we're taking a probability weighted average. We can do that in terms of y. And so we know that x just is 5 times e to the y minus 1. And so we can say that's the value of interest, but what's the probability of seeing that x? Well, that probability is just the probability of seeing that corresponding y. And so that's why when we take this integral, we can say the PDF of y multiplied by this value. Because the probability of seeing 5 times e to the y minus 1 is just the probability of seeing that corresponding y. So that's how we get to this point, but we need the PDF of y, and all we were given is the CDF, and so the next step is just to take the derivative, and we take the derivative of the exponent of e, bring that down. So negative 11 times negative 1 is just 11, so we're left with 11 times e to the negative 11y. So now plugging that back into our integral, and we can pull out the 11 and the 5, so we have a 55 constant out front, and then we have e to the y minus 1 multiplied by that e to the negative 11y, so we just distribute that in. So that becomes negative 11 plus that 1y is just e to the negative 10y minus e to the negative 11y. Finally, we are going to be taking the antiderivative. So we can just take the reciprocal. So we're going to get that negative 1/10, because when you take the derivative, the negative 10 comes down and they cancel. And same with the negative 11, so we're going to have 1/11 out front, or negative 11th out front, and then that cancels with this negative. And we're just going to plug and chug the 0 and infinity, since that is the domain space of our y. I have it all written out here, and I tend to write this out just to try to minimize the chance of messing something up. Whenever I tend to do these integrals in my head, I end up missing a negative. Distributing this negative is what I typically mess up in these types of problems, so I like to write everything out and use brackets. So when you plug in infinity, e to the negative infinity is 0, so those first terms just go away. And then over here, we're going to end up distributing this negative, and so instead of negative 1/10, we get a positive 1/10 and a negative 1/11. And so finally we're left with 55 times 1/10 minus 1/11 is just 1/2. A lot of work to get such a simple answer. So scrolling back up, we see that that falls in the range of D. So D is our final answer. As always, thank you for watching. Please consider subscribing if you find these videos helpful. Thanks.